Oh. All right, so this video is going to be on factoring techniques, specifically on factor by grouping. We're going to work on this function up top and factor it into a neat form, neat factored form, and we're going to do so using factor by grouping. So let's get it. Let's get it. Alrighty. Okay, so the first thing we do is we look at it. Is there any number from which you can divide every single element in this function that would give you a neat whole number? Okay. Or another way to put it would be, is there any factor that you can pull out of each of these elements that would give you a very neat a very neat whole number? And yeah, I mean, if you look up, we can divide 6 by 3, right? We can't really divide 5 by 3. We can't really divide x squared by 3. But you know what? Let's try it. Let's try it. So, okay, so say I want to pull out a factor of 3. Okay, so, all right, x squared divided by 3. Okay. 5x divided by 3, and then 6 divided by 3 is equal to 2. All right, so we have factored this expression. We factor out a 3 out of it, but now, I mean, I'll ask you, I mean, does this look like a simplified version of this function? No, it doesn't. It's not a fully factored form. So we're going to talk about the tool of this video, factor by grouping, which entails the idea that you take one of the elements inside of this function and you rephrase it. You rephrase it as 1, 2, or 3 terms that would say the same thing. So you know what? Let's look at this 5x sitting right in the middle. Okay. Okay. So 5x. Okay. We could say that 5x is equal to x plus 4x, right? We could say that 5x is equal to 2x plus 3x. All right. Heck, I mean, we could say that 5x is equal to x plus x plus x plus x plus x. 1, 2, 3, 4, 5. 5x. But for this problem, we're going to stick with 2x plus 3. All right. Figuring out the combination of terms that would add up to 5x, or any function that you might be dealing with, the one term you're going to be splitting apart, that's going to be up to you. But this is what this technique entails. You take a term and you rephrase it as something new in order to fit it to some kind of technique of simplifying the function. So we set the entire thing to 0 because this is a quadratic equation. And rewrite the x to the power of 2. We bring up this plus 2x plus 3x. Bring down the plus 6. Okay. And essentially these two are the same. The only thing that has changed is the way we've rephrased this side of the expression, the function of the equation. Okay. And okay, so now we do the part of this technique that it's why you call it factor by grouping, because you are factoring not the entire thing at once, you're factoring groups of it, portions of the expression or of the function that you're dealing with. Okay. So let's start by factoring this portion. Okay. And by factoring, we mean like, okay, what are the what is something that is similar between these two elements here? Okay. What is something that's similar between them that I can extract out? Okay. And I see a 2 here, and I see an x squared by itself, meaning that the coefficient in front of the variable is 1. Okay. So that's something that these two elements don't share. But what they do share is a variable of x. One has 2. One has x to the power of 2, which means x times x. Okay. And the other one has 2 times x. Okay. So we can factor this out. Okay. Meaning we recognize that the two elements share an x, so we bring it out. We make a parentheses. Okay. And we have in terms divided both of them by x. Okay. One of them crosses out, only leaving a 2. Its sign, and then the other one crosses out and only leaving 1x. Okay. Okay, so let's verify that this factored form of this group here, this group of elements, is equal to this. Okay, so distribute, we get x squared. X times x is x squared, and then x times 2 is 2x. Okay. So yes, we've got the same group of elements on both sides. Okay. Okay. Now we factor the other side. Okay. This 3x plus 6. So okay. We have 3x, which is 3 times x, and then we have 6. There's no x. You can divide both numbers by 3. So they share a 3. You could say, meaning you could say x times 3 plus 2 times 3, right? 3x plus 6. There's 3 bring it out. Plus 3. Okay. Bring down the x. Bring down the 2. Okay. Another way to look at it is that you can, again, you can divide both numbers by 3. 3 canceling out on the x, leaving it by itself, and then 6 divided by 3 being 2. Okay. And now the sort of the last part of this this recording, yeah. So the last part of this this technique is to recognize that there are two within this equation. There are there's two parts of it, right? There's the x times parentheses x plus 2, and then there's the plus 3 parentheses x plus 2. Both parentheses in this equation, in this function, are the same, meaning that we can do this. X plus 2. Okay. We can take both of them. We can say that bring them together, x plus 2, okay. And then this remaining x plus 3, we can chuck them together on another parentheses. And you can only do this if you can only do this if you have two parentheses inside of your function that are literally the same thing. And now to finish off, we verify that ultimately this is equal to that. Okay. So let's see. So hopefully is what is more? Yeah. Let's go over here. You have your x squared plus 5x plus 6 is equal to x plus 2, x plus 3. Okay. Distribute. Okay. So you have x squared. Distribute plus 3x. Distribute plus 2x. Distribute. And then you have your 6. Okay. X plus 6. Now you add up these two terms and you're left with x squared plus 5x plus 6. And as you see, this factor form is equal to the original function. And there you go. There you have it. That's how you use factor by grouping. There's many forms of factoring techniques. This is going to be one video out of the little series. All right. Let me stand over here. You can take any notes before I end the video. Alrighty. Okay, well, it's a good old 14-minute video. It's good. All right. Good luck.